When will we conquer space? It is a question we have been asking ourselves since the moment we first looked up at the night sky and understood, with a mixture of awe and terror, that the tiny lights above us were not decorations hung for our benefit, but furnaces of incomprehensible scale burning at distances our minds were never evolved to comprehend. And yet we ask the question anyway, because that is what we do. We are the species that looked at the ocean and built boats, that looked at the sky and built wings, that looked at the atom and split it open just to see what was inside. And so naturally we looked at the void between the stars and said, we will go there too. But here is the uncomfortable truth that no space agency press conference will ever lead with, no billionaire's keynote will ever confess, and no science fiction film will ever dare to dramatize honestly. We are not conquering space, we are not even close. And the reasons why have nothing to do with budget cuts or political will or the need for better rockets. The reasons are written into the fabric of physics itself, into the architecture of our own biology, into the merciless indifference of a universe that did not design itself around our ambitions and has no obligation to accommodate them. By the end of this video, I will provide you with a calculated window of when or if this might actually happen, but first, you must understand why we still don't have an answer to this question, and why that silence is more terrifying than any no. Because no implies that someone considered the question, that the universe weighed our petition and rendered a verdict, but the truth is far worse than rejection. The truth is that the cosmos has not even noticed we exist, and the barriers standing between us and the stars are not walls built to keep us out. They're simply the default state of reality, as natural and as permanent as gravity itself. And overcoming them may require not just better technology, but a fundamental transformation of what it means to be human. We're used to thinking that space is just the next frontier, a slightly more challenging version of crossing the Atlantic or mapping the interior of a continent, a problem that reduces neatly to engineering, to thrust-to-weight ratios and fuel efficiency and heat shields. And if we simply invest enough money and attract enough talent and iterate through enough prototypes, then eventually, inevitably, we will break through. This is the mythology of progress, the comfortable narrative that has carried us from the Industrial Revolution to the Information Age. And it is, when applied to the question of interplanetary and interstellar travel, almost entirely wrong. Consider our nearest neighbor, Mars, the planet we have romanticized more than any other, the planet that has inspired a century of fiction about red deserts and colonial outposts and the triumph of human will over alien terrain. Mars is, on average, 225 million kilometers from Earth, a distance that even at optimal transfer trajectories requires roughly 7 months of continuous travel through the most hostile environment our species has ever encountered. And when you arrive, what greets you is not a frontier, but a graveyard, a world with an atmospheric pressure less than 1% of Earth's, surface temperatures that swing from -20 to -73 degrees Celsius on any given day, soil saturated with toxic perchlorates that would poison any crop we try to grow in it, and no magnetosphere to speak of, meaning that every moment spent on its surface is a moment spent being irradiated by cosmic rays and solar particle events that our bodies have no defense against. We looked at our closest neighbor and found not a new home, but a confirmation that home is rarer than we ever imagined. And the further we look, the worse it gets, because Venus is a 900-degree pressure cooker with sulfuric acid clouds. Jupiter's moons are bathed in radiation belts so intense they would kill an unshielded human in hours. And beyond the gas giants lies nothing but ice and darkness for billions of kilometers until you reach the heliopause, where our sun's influence finally surrenders to the interstellar medium. We perceive these worlds as reachable, as destinations on a map waiting for us to draw the route. Yet every probe we have sent has returned the same verdict. They're radiation-soaked, chemically hostile, gravitationally punishing graveyards that reject our very DNA, not metaphorically, but literally at the molecular level. let us talk about what space actually does to a human body, not in the sanitized language of press releases, but in the clinical, unflinching terminology of the medical journals that most people never read. Cosmic radiation is the first and most insidious killer, not because it strikes suddenly like a bullet, but because it operates with the patience of entropy itself, dismantling you one cell at a time. And on Earth, we're shielded from it by two overlapping systems. The planet's magnetosphere, which deflects charged particles from the solar wind, and the atmosphere, which absorbs the secondary radiation that punches through. But in deep space beyond low Earth orbit, there is nothing. You are exposed to galactic cosmic rays, which are heavy ions accelerated to nearly the speed of light by supernova remnants and other cataclysmic events. And these particles do not merely pass through your body. They carve tunnels through your tissue, shattering DNA strands, triggering cascades of oxidative stress, and inflicting damage to neural pathways that accumulates over months and years into measurable cognitive decline. NASA's twin study published in 2019 revealed that astronaut Scott Kelly, after spending 340 days on the International Space Station, which is still within the protective envelope of Earth's magnetosphere, experienced changes to his gene expression, telomere dynamics, gut microbiome, and cognitive function that persisted for months after his return. And some of those changes appear to be permanent. His DNA was altered not by choice or design, but by the simple act of existing slightly further from Earth's surface than evolution intended. Now extrapolate that to a 7-month journey to Mars with no magnetosphere protection whatsoever, or a multi-year mission to the outer planets, or the decades-long transit times required for even the nearest stars, and you begin to understand that cosmic radiation is not an engineering problem to be solved with better shielding. Because the shielding required to block galactic cosmic rays would need to be meters thick and would add so much mass to a spacecraft that no propulsion system we currently possess or have credibly proposed could move it. Then there is the psychological dimension, the slow-motion catastrophe of isolation that we understand even less than radiation because it operates in the territory of the mind where measurement is imprecise and prediction is nearly impossible. Studies conducted in Antarctic research stations and submarine deployments and the Mars simulation habitats in Hawaii have consistently shown that prolonged isolation in confined environments produces a predictable arc of psychological deterioration. Initial enthusiasm gives way to irritability, irritability to depression, depression to interpersonal conflict, and conflict to a kind of emotional entropy where the crew simply stops functioning as a coherent unit. And this is in environments where rescue is possible, where communication with Earth is instantaneous, where the participants know at a fundamental level that they can leave. Now imagine a crew of 6 sealed inside a vessel the size of a small apartment, hurtling through absolute darkness at speeds that nonetheless feel like standing still because there are no reference points, no landmarks, no horizon, nothing outside the windows but the unchanging void, and the nearest human being who is not on that ship is millions of kilometers away and receding. And every second that passes makes rescue more impossible and return more theoretical. The psychological models we have suggest that under these conditions the human mind does not adapt, it fractures. And beneath all of this, beneath the radiation and the psychology and the engineering challenges, there's the most fundamental barrier of all, distance, the raw, crushing, incomprehensible scale of the vacuum between objects in space. We speak of traveling to Mars as if it were a commute, but even at its closest approach, Mars is 55 million kilometers away, a distance that light covers in 3 minutes, but that our fastest spacecraft would take months to cross. And Mars is in our backyard. It shares our orbit around the same star. It is cosmically speaking pressed against us like a neighbor leaning over the fence. The nearest star system, Alpha Centauri, is 4.37 light years away, which translates to roughly 40 trillion kilometers and our fastest probe ever launched. The Parker Solar Probe at its peak velocity of around 635,000 kilometers per hour would take approximately 6,700 years to reach it. 6,700 years. That is longer than all of recorded human history. Longer than the gap between the construction of the Great Pyramid and this moment right now. We have not left low Earth orbit with a human crew since December of 1972, over 50 years ago. And if you ask the honest engineers and mission planners why, they will not cite budget constraints or political apathy. They will tell you that we hit something, not a wall exactly, but a threshold, a point where the challenges stop scaling linearly and start scaling exponentially, where every additional kilometer of distance from Earth multiplies the risk and the cost and the complexity, not by increments, but by orders of magnitude. If you want to support our mission to document these uncomfortable truths, consider subscribing. It is the only way to ensure this signal keeps reaching you across the void, because the algorithms that govern what you see are as indifferent as the cosmos itself. And without your active choice to stay connected, this conversation disappears into the noise. Now I want you to hold all of these facts in your mind simultaneously. The radiation that rewrites your genome, the psychological entropy that dissolves crew cohesion, the distances that mock our fastest machines, the hostile chemistry of every world we have examined, the 50-year gap since our last crewed mission beyond low Earth orbit. And I want you to consider the possibility that these are not separate problems requiring separate solutions, that they are not independent obstacles on a checklist to be ticked off one by one as our technology matures. What if they are all symptoms of a single, deeper truth? What if the universe is not a frontier waiting to be crossed, but an environment that is fundamentally, structurally, perhaps even intentionally incompatible with biological life traveling through it? What if every barrier we encounter is not a puzzle to be solved, but a boundary condition, as intrinsic to the cosmos as the speed of light or the second law of thermodynamics? A limit that cannot be engineered around, because it is woven into the same physics that makes our existence possible in the first place. There is a concept in astrobiology called the Great Filter, originally proposed by economist Robin Hanson in 1996, and it suggests that somewhere between dead matter and a galaxy-spanning civilization, there is a barrier so formidable that virtually no species in the history of the universe has ever crossed it. And the terrifying question is whether that filter lies behind us, in the improbable emergence of life, or the unlikely evolution of complex multicellular organisms, or ahead of us in the very step we are now attempting, the step from planetary species to spacefaring civilization. Because if the filter is ahead of us, then every failed attempt to leave our planet, every mission scrubbed, every technology that falls short, every astronaut whose body breaks down under the strain of microgravity and radiation is not merely a setback, but evidence of a cosmic pattern, a pattern that suggests that the universe produces intelligent life with extraordinary rarity and then contains it, cradles it, imprisons it on the single fragile world where conditions happen to be right, and that no amount of ingenuity or determination or funding can overcome this containment, because it is not a flaw in our approach, but a feature of reality. Konstantin Tsiolkovsky, the father of rocketry, wrote in 1911 that Earth is the cradle of humanity, but one cannot live in a cradle forever. But what if Tsiolkovsky was wrong? Not about the cradle, but about the leaving. What if the cradle is not a temporary dwelling, but a permanent address? What if the universe built us a single room and locked the door and swallowed the key? So let me now fulfill the promise I made at the beginning and give you the calculated window. For Mars, the most optimistic, credible timeline places a sustained human presence. Not a flag-planting visit, but an actual self-sustaining colony capable of surviving without continuous resupply from Earth, somewhere between 100 and 150 years from now. And this assumes breakthroughs in radiation shielding, closed-loop life support, in situ resource utilization, and psychological support systems that we have not yet achieved, and in some cases have not yet seriously begun to develop. The more conservative estimates from researchers at MIT and the European Space Agency place this milestone at 200 to 300 years, and some models suggest it may never be achievable with biological humans at all, that the colonization of Mars may ultimately require engineered organisms or artificial intelligence or a hybrid of both. For the outer solar system, the moons of Jupiter and Saturn, where liquid water exists beneath ice shells, the timeline extends to 500 years or more. These are not arbitrary numbers. They're derived from extrapolating current rates of technological progress and accounting for the exponential increase in complexity that each additional 100 million kilometers of distance introduces. And for the stars, for Alpha Centauri and Tau Ceti and the thousands of exoplanets we have cataloged but will never touch with human hands under current physics. The honest answer is measured in millennia, if it is possible at all, because to cross interstellar distances within a human lifetime would require either propulsion systems that approach a significant fraction of light speed, which would demand energy outputs equivalent to the total annual energy consumption of our entire civilization concentrated into a single engine burn, or generation ships designed to sustain populations for centuries in the void, which would require solving every single biological, psychological, and social problem I have described, and dozens more we have not yet identified. The Kardashev scale, proposed by Soviet astronomer Nikolai Kardashev in 1964, classifies civilizations by their energy consumption. Type 1 harnesses all available energy on their home planet. Type 2 harnesses the total energy output of their star. Type 3 harnesses the energy of their entire galaxy. Humanity currently sits at approximately 0.73 on this scale. We have not yet even fully mastered the resources of our own world, and the jump from Type 0 to Type 1 alone is estimated to require between 100 and 200 years of continuous development without civilizational collapse, war, or environmental catastrophe. The stars are not merely far away. They are far away in a way that makes the word far meaningless. They exist at distances that transform travel from an engineering challenge into a philosophical one. Because to reach them, we would need to become something other than what we currently are, not just technologically, but biologically, psychologically, perhaps even spiritually. And so, I leave you with the question that has haunted every astronomer who has ever stared too long into the abyss between the stars and felt it staring back. If the stars are out of reach, does that make Earth a sanctuary or a prison cell? Is this planet the cradle that Tsiolkovsky described, a warm and temporary shelter from which we will one day emerge transformed and ready? Or is it the only room in an infinite house that we were ever meant to occupy? A single island of warmth in an ocean of cold that stretches in every direction without end or mercy or meaning. And if you knew, truly knew, with the certainty of a mathematical proof, that you would never return, that the journey would consume your life and the lives of your children and their children after them, that the destination might be nothing more than another dead rock orbiting another indifferent star, would you still choose to leave? Or would you stay, tend the garden, watch the sunset, and make peace with the fact that this pale blue that is not a launching pad but a destination? Not a beginning, but the entire story. Tell me in the comments, because the answer reveals more about you than any telescope could ever reveal about the stars, and is a question that our species will have to answer collectively, not in a century, not in a millennium, but now, because the decisions we make about our planet today will determine whether the cradle remains habitable long enough for us to even have the luxury of dreaming about escape. The universe is under no obligation to make sense to us. It is under no obligation to be kind, and it is under no obligation to wait. The clock is already running, and the silence between the stars is not an invitation. It is the answer we have been refusing to hear.